All right, we're going over notes on solving two-step equations. This is Miss Starling. And I'm doing this the week of 10/5 through 10/9, depending upon what day you're in my class, and all of my periods. So two-step equations means I am doing two things, those things being operations, to solve. So I'm working backwards. I'm undoing addition or subtraction with the inverse or opposite operation. And I'm doing multiplication or division, again, with the inverse operation. So addition and subtraction are opposites, and multiplication and division are opposites. I'm going to isolate the variable to solve, and I'm going to check my solution, which is my answer. Okay, down here it says use the models below to solve the equation. So this is a visual version of an algebraic equation. They just use bar models and units to represent the x's and the ones. Sometimes these will be negative. Sometimes these are negative ones. Okay? Well, negative ones. Put a little s there. So this just means 2 x's and 4 ones equals 3 ones. And in order to solve this, I'm going to demonstrate using the visual, and then I'll show the equation version or the arithmetic. So if I have 4 ones over here, I need to make all of these negative and bring them over here. So I'm going to cross these out, 1, 2, 3, 4. Then I need to cross out 4 over here, 1, 2, 3. I don't have a fourth one, so I need to make it the opposite, which is negative 1. And that is what I will be left with. So I'm subtracting 4 and subtracting 4. So if I make another one, I have to make a 0 pair, which is a positive 1 and a negative 1. That way I can cross out that, and I'm left with negative 4. I'm sorry, I'm left with negative 1. Now I have 2 x's. Equals negative 1. So this negative 1 I have to split in half. So what that looks like visually is 2 bars, x, another bar, x, and then I have to split this in half, negative 0.5, and another negative 0.5. So each x is worth a negative half. X equals negative 0.5. Or x equals negative 1/2. And then this is my answer. Okay, so I did show you the arithmetic over here. Now I'm literally just going to cross out. So I have 2 ones over here, and I have 8 ones over here. So I'm going to cross out 2, and I'm going to cross out 2. Now I have 3 groups, 1, 2, 3, and I need to split these into 3 groups. So 1, 2, 3. So for every x, I need to determine how many ones I have. Each x is 2 ones. Therefore, x equals 2. So that's how you do the model. Now, to do it the arithmetic way, I'm going to do what we discussed in class the other day. So I'm going to draw a river through my equal sign. And then the 3 is attached to the k, so I have to get rid of the 3 last, and I have to get rid of the 10 first. This 10 is a positive 10, so I'm going to do the opposite, which is negative 10. And if I do it to the left, I have to do it to the right. Negative 10. Notice I don't write a negative 10 here. And oh, that pencil's not going to work. Here and here, because these two 10s are on the same side. And I have to do one thing to the other side and one thing to the opposite side. So I can't put minus 10, minus 10. So I just put negative 10 on the left and negative 10 on the right. And I put it right below its 10, so it's easy for me to cross out, or right below its inverse. Then I'm left with 3x, or 3k. And 22 minus 10 is 12. Now, as we also stated in class, this says 3 times a number is 12. Well, I know that number is 4, but what am I doing with what I'm given to solve it? I'm going to divide. Divide by 3 and divide by 3. K is equal to 12 divided by 3, which is 4. Put a box around it and move on. So the next one, I'm going to draw a river through my equal sign. And I have to get rid of the 4 last because it's attached to the P. So this says minus 5. I'm going to do the opposite of minus 5, which is plus 5. This negative 5 and positive 5 are going to cancel out. Then I have 4p, and 19 plus 5 is 24. Now I've already added or subtracted, so my next step is multiplication or division. And in this case, I'm going to divide by 4, because if I multiply by 4, I'll end up getting 16p, and I don't want to get a bigger p, I want to get 1p. So this says 4 times 4. I'm going to divide by 4. On both sides, these 4's cancel out. P is equal to 24 divided by 4, which is 6. Oh, and then at the bottom it has a check, so I'll go back and check in a moment. Lastly, draw a river. This is minus 8. So the opposite of minus 8 is plus 8 on both sides. These 8's cancel out. This is r divided by 2 equals 16 plus 8, which is 24. And the opposite of division is multiplication. So I'm going to multiply by 2 on the left, and I'm going to multiply by 2 on the right. These 2's will get canceled out over here, and I'll have r equals 24 times 2, which is 48. Now I've got to check to see if it works. So how do I check? I go back and I substitute or plug in the variable. Substitute. Whoops, substitute though. Or plug in. That means I'm taking out K and I'm putting in 4. I'm taking out P and I'm putting in 6. And I'm taking out R and I'm putting in 48. Here's what that looks like. Oops. Negative 10 plus 3K equals 22. K is 4. So I'm going to put negative 10 plus 3. Oh, not negative 10. Why didn't you tell me it's not negative? My bad. Regular 10. I was looking at this negative 10. Regular 10 plus 3K equals 24. So 10 plus 3 And then parentheses, I'll put in a 4 here, equals 22. So order of operations tells me I have to multiply first, which is 3 times 4, and that's 12. So 10 plus 12 equals 22. And then whatever I do to the left, I must double check to see if it's equal to the right. So 10 plus 12 is 22, equals 22, and it checks. It's correct. Next, I'm going to do P equals 6. So 19 equals 4P minus 5. I'm going to take out P and I'm going to put in 6. So 19 equals 4 times 6 minus 5. 19 equals 4 times 6 is 24 minus 5. 19 equals, do the math, 24 minus 5 is 19, and it checks out. Last one on this page, R over 2 minus 8 equals 16. So now I'm going to take out R and put in 48. 48 halves minus 8 equals 16. Half of 48 is 24. Minus 8 equals 16. The left equals the right. And that means I did it correctly. Okay, on to the next page. So on that previous page, we had just rational or integer numbers. Now we have rational. So we're solving two sub-equations with rationals. Equations with rational numbers can be solved just like any equation. You must follow the rules for integers and rationals. So that's the same signs add and keep, different signs subtract. Keep the sign of the greater absolute value, then you'll be exact. Multiply or divide, it's an easy thought. Same signs are positive, different signs are not. So they're going to jog your memory down here. When you're adding integers, if the two values have the same sign, then you add and keep that sign. Same signs add and keep, different signs subtract. If the signs are different, then subtract and keep the sign of the greater absolute value. And this is for adding integers. Down here for subtracting, I want to rewrite the problem to add the opposite. Then follow the rules for adding integers. So it's whenever you see a minus sign, it's going to become 6 plus negative 7, negative 9 plus negative 11, and negative 3 plus 8. This double negative means positive. Double negative. Okay. Multiply or divide the two numbers. And then if the signs are the same, then the answer is positive. And if the signs are different, the answer is negative. Okay, so then let's practice these down here, and then we'll go on to do some equations. So negative 6 plus negative 19, this is the same sign, so I'm going to add 6 plus 19 is negative 25. 5 minus 32, this is 5 plus negative 32. This is negative 27. 14 plus negative 27, these are different signs, subtract. So that's going to be 3, 1, negative. 27 minus 14, let me double check, 3, 1. Okay. Negative 11 plus negative 8 is negative 19. Circle it, move on. My video is about to stop.